Okay, cool. Let me see. I'll get the Q&A up as well, just in case anyone would like to ask any questions during this. Um, so we run these webinars. I work for a firm called Jumping Rivers. Um, and the webinar that I'm presenting today is part of a series of webinars that we run, typically on a kind of monthly basis. Um, and yeah, however, this is the second of this year. Um, I'm going to be talking about two Python libraries, Pandas, which is extremely well known in the Python data community, and Polars, which is a relative newcomer, but is also well thought of and is pretty established within Python too. Um, they both address a very similar aspect of data work within Python. And I'm hoping to reveal that to you during the webinar. My name's Russ Hyde. I am a data scientist at Jumping Rivers here in the UK. And I kind of specialize in the data presentation applications and things like that within R and Python. Yeah, so today we're talking about Python. Jumping Rivers as a whole, we are a company, we're a data science consultancy, so we can do things like fix data applications, build data pipelines and things like that. But we're not just data science, we're also engineering support. We can provide infrastructure, things like the professional R products, the professional POSIT products like POSIT Connect for hosting data applications and pipelines and things. And we also do a lot of training in R, Python, SQL, the things that you, as a data scientist, ought to be, you know, comfortable using. A more recent area of expertise within Jumping Rivers is on kind of validating open source packages, open source tooling for use in regulated industries like insurance and pharma and things, where it's, you know, traditionally quite hard to get new versions of packages or new packages available to you within an environment. So we provide some help along them lines to make it a bit more easy to work with cutting edge tools in the open source world in those industries. So um, today, so I've got 44 participants. That feels like a good number to get into the body of this webinar. This is based on a recent blog post. I wrote a blog post in November comparing the syntax for polars and pandas, these two different data frame libraries within Python. And I've been asked if I'm going to be sharing the slides from the talk. I'm not going to be sharing the slides directly, but the talk itself will be shared on YouTube. And really, the content for the talk is a little bit of what's already in this blog post and a little bit extra. So I think the video itself should be sufficient to be able to reproduce what I've got. So we're comparing polars and pandas. This blog post came out at the time that version 3 of pandas had just been released. So until November, we were on pandas version 2, and that change introduced a small additional bit of syntax. From a user of pandas perspective, it was a relatively small change. A lot of internal kind of memory management type things changed from Pandas 2 to Pandas 3, but as a user of the library, there was relatively little change in terms of how you use it, in terms of what code you would write. Right. So that's the basics. The QR code I've got here, and if you're viewing this on YouTube or something at a later date, you can take a photo of that QR code. It will take you to our blog posts, and we've got blog posts that are coming out on a regular basis, typically once a week, if not more. Some quite technical ones, some, more about what we do as a company. So, the tools that we're talking about, Pandas and Polars, their bread and butter is working with data sets that can comfortably fit in the memory of your machine, be that your laptop or whatever supercomputer you're working with. That isn't the only thing that they're good for. You can use them with data sets that are bigger than memory, but the most typical use case is when you're working with data sets that are smaller than memory. And invariably with rectangular data, that's something akin to like an Excel spreadsheet or a database table where you have columns and rows in your data set. I've told you the two libraries that we're looking at. Pandas has been available in Python for a long time. Polars is a more recent thing. Polars internally is quite distinct. It's built using the Rust programming language. And one of the great things about the Rust programming language is it has really good memory management. And what that means as a user of a data tool is that by building on Rust, we can take advantage of the memory management that Rust provides, but from Python. And that means that, you can refer to a data frame multiple times within a Jupyter notebook or something like that without the amount of memory stored within that Jupyter notebook exploding. Anyway, so we're going to be looking at those two libraries. But the big thing that you need to take from this is that you should make an effort to experiment with new tools. Now, Polars isn't a new tool, really. But it might be a tool that you're not experienced with. And so if it's a new tool from your perspective, it's a new tool. In the data world, if new tools are coming out on a regular basis, and if you need to, if you're using Pandas on a day-to-day basis, it might be worth you experimenting with Polars. It sits in the same kind of domain. Its syntax is slightly different. It does have some benefits in terms of memory management and and in terms of some of the syntax it uses. And you may end up collaborating with teams, or your team may evolve to use a different tool in such a way that, if you miss out, you might not be able to collaborate as effectively with a team that works with a different tool. Right. This is a image of a typical data science workflow. I've taken it from the book R for Data Science, which is kind of the a standard text within data science in the R community, but the ideas in this image are language agnostic. We are going to be focusing on importing, cleaning up data, and transforming it. We're not going to be doing any like data visualization, any statistical analysis or anything like that. And we're not going to be doing like automated reporting or anything in this webinar. Where did my experiment? Ah, right, yeah. Okay, so the tools are for rectangling. That is working with row and column oriented data sets. The data sets that we did, so these are something that you might typically import from an Excel file or from a comma separated plain text file or from a table within a database where within a given column you have all the entries are of the same data type. So you might have in an age column, say, have numbers from head to tail. Or in your name column, you might have strings from top to bottom. No mixing of data types within a given column, but you can have different data types across the columns. Okay. In Python, there's a lot of information on this slide. You would be able to find this information elsewhere quite easily. This is, if you want to experiment with a new library in Python, what do you have to do to set that up? And basically, you have to set up something called a virtual environment, which is an isolated place that you can install packages. So it won't affect your the Python that your system needs to run kind of everyday tasks, and the um, it won't affect your work projects. Things that you're actually working on that are critical. So you set up an isolated environment, and using that isolated environment, you kind of activate it, and then you can use Python, but just the packages that have been installed for that particular environment. In the example here, I'm going to be using Jupyter Notebooks. And in order to use Jupyter Notebooks, I need to make something called a kernel. These two lines here show you how to make a kernel that you can use in a Jupyter Notebook. Anyway, so the reason for doing that is so that you don't break your system, you can experiment with ease, and you don't mess up any of your work projects. Okay. So here we're using Python 3.14. So this is, say, the path to a copy of Python on my system. I'm creating a virtual environment and installing Pandas 3. So that's one of the new versions of Pandas, and whatever the most recent version of Polars was a couple of weeks ago when I wrote this slide. Okay, so that makes me a kernel. I can use that from a Jupyter notebook. Okay, so I could go in to Jupyter here and load pandas, import it. We typically import library pandas and polars using little aliases pd and pl. If I insert below, I can see that pd version, oops, is 3.01, the version that I've just installed according to the slides, right? So the first thing that you would want to do with a data frame library is import some data. And the syntax between the two libraries is almost identical. You use read CSV if you're pulling data from a comma separated file or a tab separated file or whatever. Here we pass in a file path. You don't need the specifics of the file path. And sometimes in Pandas, you have to indicate how that data was encoded, the kind of format, the format specifier for the file that you've read in. But ultimately, you're just using a function called read CSV to read in some data. So in Pandas, we have the same code written in here. If I run that, I'll come back to some of the questions that have been asked because there's a couple in the Q&A. So this is reading data in, and then I've just printed out the data frame to the screen. The data set, there's a row, well, there's like 20,000 rows in this data set. The way the data set was made is small regions of the UK were assessed for their biodiversity. So you've got a region here, 21405,709, and within that region, they have looked for specific insects and recorded any that they found. Recorded the particular species, whether it was male or female, and how many they found. Okay, and though that kind of that kind of study has been done in multiple regions of the UK, small little sectors, and across multiple years. It's a really useful data set. It's really interesting for this kind of work where you're like comparing things. So I've read in that. Maybe I don't want to look at every insect within the data set. Maybe I want to filter it first. And how do we do that in pandas? This is quite a typical thing that you'd need to do. In pandas, you use these square brackets. Square brackets are used to select subsets of the columns of a data frame or to select specific rows of a data frame that you want to keep. Inside that square bracket, I'm doing a kind of comparison whether the order column matches this particular pattern here. So that will pull out bees and wasps and things like that. So this comparison will make a series of like true and false type values. If I show you that. So I've got insert above. If I do pollinators order equals that, it'll tell me, I think the first 3 entries are true and then a few falses and things like that. That kind of series of true and false values can be used to index into a data frame, and pandas will know that you're trying to make a subset of the rows if you pass it in one of those data masks. A data mask is like a series of true and false values. So that allows me to filter to just the, where were we? Hymenoptera, the bees. Okay. That's filtering. There is an alternative syntax in pandas that uses a method called ilock, which is a more explicit way of telling pandas I'm referring to this data frame by row, and it's specific rows that I want to pull out. That's a way of locating rows by index. Okay. Okay, so that's how you would filter data within pandas. That's not all that you might want to do. Once you've got the data that you want, you might want to do some summaries, and there's a little bit complicated syntax coming in on the next slide. Here, we're taking the bees data frame that we've just set up. Now, within that data frame, there's a sample ID column. That's the position around the UK that was assessed for different species and things. Each of those sample IDs, they're kind of nested within years. So there's a range of sample IDs for 2017, a range of sample IDs for 2018, and there's no overlap between the sample IDs for a given year, but we've grouped that data frame up. What that does is it chunks it up. You get a chunk for 2017 in this particular location, a chunk for 2017 in this other location, and so on, across the different years and locations. And then we're going to do a summary within each of those separate chunks. So we group and then we use a method called aggregate. If I show you the data, it might be clearer what goes on there. So we've got grouping and then aggregation. So if you look at the input data, we've got a sample ID, we've got a year on the right-hand side, and we've got, what is it now? So, count should be there. There's a count column, and there's a taxon standardized column. We're going to be using those two columns, count and taxon standardized. We're going to be summing up the number of each type of bee that was observed in a given region. So that's the number of animals, the number of insects in total. The second one will give us the number of distinct species of insect within a given region. So here in aggregate, we use count on the left-hand side of this colon to indicate which column we're going to summarize over. And in the right-hand side, we use the name of the function that we want to use to summarize that data. Some will just add up values. Here we're using something called a lambda function, which is a Python-specific way of kind of writing a kind of anonymous function, a function that you don't need to define using def, a kind of function that you will basically just throw away after its initial use. So what that will do is it'll take the current data frame chunk and count up the number of unique values within the taxon standardized column for that thing. Doing that, the sample ID and year, the thing that we grouped on, become the index of the data frame. And the count and the taxon standardized, they are the names of the columns in the output data frame. We can actually rename them if we want using the rename method. And that will change count to number of insects and taxon standardized to number of species, which may be more illuminating column names for you for your subsequent work. Right, so what have we done? We've grouped, summarized, and then renamed the things. Okay, so there's three separate methods that we've used there. And when we're presenting those things, we can use a fourth method called sort values, and that takes a named column within a given data frame and sorts them, and we can do it with the values ascending or descending. Right. Finally, the final thing that I want to show you is how to do things like create a new column of data. So this is like summarizing existing columns of data and renaming columns and things. If we want to compute a new column of data, we can use another piece of syntax. So if I go above here and I take the pollinators data set, say, to begin with, pollinators it has a year column. Year. The first year that this study was done was 2017, and I might want to store which was the first, which was the second, which was the third year of the study. And I can compute that relatively simply by taking the year column itself and subtracting the minimum value from that column. And that's what's going on the right-hand side. So I compute a new vector of values that's going to have 20,000 entries within it. On the left-hand side, it looks like I'm referring to a column that doesn't exist in the data frame. And what I'm doing is actually adding a new data frame column called year of study. If I run the whole thing, and then print out its contents, you can see that we've computed a new column called year of study using the values within the year column. Okay, so that's adding a new column. There are other ways of doing it. There's a method called assign, and with assign, you you can um, you can basically give the name of the column that you want to create as if it was an argument to the method. So year of study looks like it's an argument to this method. And we can use one of those anonymous functions again to tell pandas how to compute the values for this column that we're going to create. Pollinators.assign. So that's using assign, and here we're using the square bracket indexing thing in pandas. Okay. Assign is a little more useful than square brackets if you ever have to chain together multiple things. If we wanted to do grouping and then aggregation and then renaming and then compute a new column, we can pass the results from one of those steps to the next. And assign is more useful than the square brackets there, because it can work with the current state of the data frame that was passed into it. To use the square brackets, we have to kind of refer to a realized, a kind of concrete data frame in order to add a new column using the square brackets. So assign's a bit more useful in a chain of methods. Right. Finally, polars. Polars syntax is largely you can do exactly the same processes in polars as you could in pandas. And things like reading a file is almost identical to pandas. So you use the read CSV method from polars. So if I load polars and I use read CSV, I get the same data set. One of the key differences here is that polars requires you to tell it either to tell it what the columns of that data set should contain, whether this is a string and that's a number and this is a date and things like that, by providing a schema to it, or it expects you to tell it, you can work out the schema for yourself. And what I've done here is say, read the first 10,000 lines of the data set and work out which columns are number and which columns are string yourself. Okay. So polars needs a schema, but pandas doesn't necessarily. And but otherwise, reading is almost identical to us in pandas. You can use the square brackets to extract a specific column from a data frame in polars, or a specific set of columns from a data set. But that the syntax where you use the square bracket and a series of true and false values, that doesn't work in polars. So rather than using the square brackets, what we use is a method called filter. So you have your data frame, and you call the filter method that is associated with that data frame with a little expression. So here, what we're telling it is extract this particular column, the order column, and check whether it matches this particular pattern. Okay, so that's the logical syntax for determining which row you want to keep is the same, but how you use that collection of true and false values to select the rows is slightly different. We use filter method rather than the square bracket in polars. pl.col it's quite a common way of defining an expression within polars to apply to a data frame. Okay, so if we go to the Polars demo and I can filter, filter with that, we get the same collection of 9,000 or so values. In Jupyter, the data frame still prints out in almost exactly the same format. You can still see the different entries within the columns and stuff, and it just shows the top five and the bottom five entries, like it did for Pandas. Um, so it works in Jupyter just as nicely, but some of the methods are different. Um, Summarizing. Now, this looks very similar to what we had in Pandas. We've got two methods that we need, group by and ag. Again, ag is like a aggregation type thing. It's a way of summarizing within a chunked up data frame. Again, we're going to be grouping by the same, by location and year. And within a given location year combination, we're going to summarize by adding up the count column and by counting the number of unique values with the number of unique species within it. But the syntax to do that is slightly different. So here we extract the count column from a subset of a data frame and then sum up its value. So this is the expression to do that. Here we extract the taxon column and extract its unique values and then count how many unique values there were in. If you compare that to how we did it in Pandas, here we tell Pandas what function to apply to compute the thing that we want to compute. In Polars, we have to tell him over which column to work and then what method or function to apply to that column. The aggregate thing in Polars, you don't need the rename step. You can specify what the column's name is going to be during the summary step. So that's quite neat. That saves you an extra method call if you want to compute a value and call it this. And it also means that you can do multiple summaries on the same column or over collections of columns and things like that. So that's quite useful. You can do that in Pandas, but the syntax gets a bit complicated. Right. Grouping and aggregation. The final thing was, how do we compute values to add to a new column? There are two different ways to do this in Polars. There's a method called with columns and there's a method called select. And we'll look at with columns first. So what that does is it will return you a data frame that contains all of the initial columns of the data frame, potentially plus some extras. So we're going to compute the year of study column by taking the year column and the minimum of the year column. So we're going to compute, subtract the minimum year from all of the year values in a given column. So this is the expression to compute what we want to put. And this is a method that we need to call on that to tell Polars what the name of that new column is going to be. So we use alias to indicate what the column should be called. In Pandas, when we did that, to be honest, with a sign, it looks a bit neater. You specify on the left-hand side what the column's going to be called. But yeah, so we use this alias thing in Polars to do that. In the demo script, let's have a see. So we've got counts and we can with columns. We call it, so you have to look at the very right hand side to see what the new column is going to be called. That adds an extra column to the existing columns called year of study. And okay, the other method that I wanted to show was select. And what that is a way of extracting specific columns from a data frame. So you might not want all 12 columns in this data frame in your output, but you can specify, say, I want the sample ID and the year thing, the thing that we grouped upon, and this new column that I'm going to define. So rather than adding the year of study thing to the end of the data frame, you're extracting specific columns. And the syntax for the expression for how to compute the year of study thing is identical to how you do it using with columns. But with select, you control what are the columns going to be called, which specific columns I want to extract from the data frame when I do this. So in the demo, if I do that, you should just get 3 columns back out. Dot select. That tells it that you want the sample ID and year column, and that explains that you want to create the year of study column while you're doing it. Okay, that's largely what I wanted to show you for polars and pandas. The final thing was something that Pandas version 3 introduced. Pandas version 3, all of the syntax for version 2 of Pandas will work in version 3. But there's an extra thing called pd.col, which is kind of reminiscent of what goes on in polars. So we had pl.col to refer to specific columns. Why is this useful in Pandas? Because we already knew how to filter a data set with a Boolean mask or using a lambda function. What we can do with the Pandas version 3 syntax is we have pd.col. We can refer to a column within the current state of the data frame, rather than having to use a lambda function to refer to a subset of the data frame within its current state. So that's quite neat. It works for filtering like this, and it works within an assignment statement. And the beauty of having that is that you can have a chain of methods and have, halfway through that chain of methods, the data frame state doesn't, that specific data frame doesn't have a name at that point. So you can refer to a named column within it using pd.col. So that's quite useful. But otherwise, it's not very different from the old Pandas syntax. So that's the end of what I wanted to present. We've got some questions in the Q&A. Please ask any extras if you've got any. I have to show this legally. The data set that we've just been presented on, there's a data citation that says, if you use this data, please put this citation up. So for the teaching purposes that we're doing today, I have to show it. But basically, this is a data set funded by the UK government that you can download from from a website. The website, the URL for it is in the blog post that I mentioned. And you can work with it. There's some very interesting data sets in there. I should mention we've got a conference in June. If you're using LLMs, if you're using like coding, AI-driven coding tools or anything like that within your software development or within the products that you're making for clients, or if you're just interested in AI and what's happening and how to use it in a production setting, this is the conference for you. I'll leave the QR code up while I answer some questions. Okay, so the first question was, will I be sharing the slides? Now, I'm not going to be sharing the slides. And the reason I'm not going to be sharing the slides is the video itself is going to be shared. It's going to be on our YouTube channel, and you'll be able to view it there. The slides don't show much more content than you'd want there. Aside from the um, how to add a new column to a data frame. All of the content that I've just presented is in a blog post that's on our website, and you can go to that if you find the Jumping Rivers blog and you search for polars, it'll probably be the only blog post in there at the moment. Right. Next question. Will much of this change if we experiment with Impositron using a .py script? Oh, sorry, this must refer to setting up a virtual environment. If you're working in the traditional Python .py suffixed scripts, then you don't need to create a kernel when you prepare a virtual environment. So you can make a virtual environment with just the packages that you want to experiment with without making a Jupyter kernel if you're just working within a .py setting. Yeah, so that's fine. And if you've activated the virtual environment, when you call Python or when you enter the Python interpreter, it will be the virtual environment version of Python that you'll be working with there. Yes, the recording will be shared. Once a dataset exceeds the memory capacity of your computer, what libraries would you recommend looking into? Now, it really depends how far exceeded the data is. If it still fits on a computer, if it fits in your hard drive, but not necessarily in your memory, then you've got a few quite neat choices. You've got, now what is it? Dask. You've got various database type solutions like you know, SQLite and things like that. You can access that will work with data of that size. DuckDB is geared towards data analytics, and if you're working with data on that is smaller than your hard drive but bigger than your memory, it's an extremely good solution for that kind of stuff. But Polars is capable of working with data that is bigger than memory. A lot of the stuff that I've shown you is just kind of how to use Polars and what the syntax looks like and things like that. But there's a way of setting up to use Polars that means you can work with out of memory size data sets. And if you use that syntax, it will only like pull data into your Jupyter session or something once it has already been summarized. It will be able to chunk things in the background and bring the results that you actually need back into. What would I say is the so yes, so there's lots of solutions. If your data is bigger than a single computer can hold, or it working with it on a single computer imposes like input and output constraints that mean it, you know, it's too slow to work with on a single machine. You can spread it across multiple machines and use something like Spark to work with it. Finally, what is the biggest advantage? The biggest advantage of Polars over Pandas. I expected it to be that Polars would be more efficient, that it would mean that my Jupyter sessions crashed less often. I expected it to be that the memory footprint of a Polars session would be smaller than a pandas session, just because of how the two are designed. Um, but I don't think that's the benefit of polars. I think the benefit of polars is really that its syntax is a little more elegant, that the way that it's more readily geared towards chaining um, analytical steps together uh, is really its benefit. But some of that syntax that Polars has introduced is being introduced into Pandas as we speak, it seems, as you can see through pd.col being introduced. Pandas, the main benefit of Pandas is that it's so well known, that there's so much extremely good documentation on it. In fact, the best entry level data analysis book for Python was written by the Pandas author and emphasizes the use of Pandas throughout it. So a great many of those of us who do use Python for data analysis learned it in data analysis, sorry, Python for data analysis, using Pandas. But yeah, I mean, Pandas syntax is kind of common across a lot of other data frame libraries. So learning how to use pandas effectively is quite useful when you step into things like Dask and other things as well. Anyway, right. Thanks for all your questions and thanks for your time today. Hopefully it has been useful to you all. Yeah, but the key thing is go away, learn a new library. If there's something that you rely upon, try using the latest version of that package first, or using a package that you are unfamiliar with that does the same kind of thing. You know, it, because experimenting with those libraries may solve a problem you didn't even know you had. You may find that things are considerably faster when you use Dask or when you use Polars than they are when you use Pandas. Or you might find, you know, if you're experimenting with a data visualization library, that it just makes better looking graphs than you could in the old library that you were using. Anyway, thanks ever so much for coming along. And I wish you good luck with everything, and hopefully the webinar's been useful. Yeah, let me know. I'm on LinkedIn via Jumping Rivers if you want to speak to us, if you want to give us any feedback on the webinar or anything like that. Thanks ever so much for coming along.